Hi, everyone. Thank you for having me at Tech Talk. My name is Behzad. Today, I'm going to talk to you about coding for the rest of us. And I know that the audience are very diverse here. Some of them are computer scientists and software engineers. My message to them is that don't take your skills for granted and please share them. There are many people who can benefit from your skills. Other part of the audience might be the people who have written code, but not as a member of a team. So I might be able to show you some tools that you can use to make collaboration easier for you. And the other part of the audience might be people who have always wanted to have their own website, but they didn't know where to start. I might be able to show you some shortcuts without doing much programming. You can make your own website. So to begin with, I would just briefly introduce myself. I have studied electrical engineering back in Iran for my undergrad and master's. I then worked for an R&D center of a car manufacturing company called Irankhodro. And then I moved to Montreal. I studied my PhD in mechanical engineering at Concordia University. However, in both electrical engineering and mechanical engineering, my interest has always been control systems. After getting my PhD, I went back to Iran. I became an assistant professor at Tehran Polytechnic, Amirkabir University. So I was there for 3 years, 3 good years, very good experience, great students. And then I came back to Canada and I joined Maplesoft. There we were working with Japanese car manufacturers, including Toyota. After 7 years, I left Maplesoft to join a software startup in Toronto to do machine learning. I just wanted to have like more experience in machine learning. But it didn't go really well. So after 2.5 months, I was fired from the company. And at the time, I thought maybe I should start my own company. So I founded Nubunetics for cloud robotics. And my first client and last one was Advanced Intelligence Systems in Burnaby, British Columbia. And I loved the team so much and the project so much that I joined them as of 2020. So I'm just going to show you what we do here. So the company was founded in late 2013. We built practical robots. The robots that are highly autonomous. They are affordable because we offer them as a service. They are upgradable because of their modular design. And they require minimum changes to the infrastructure. So this is the first robot that we built. It's called Big Top for spacing plant pots. And when the pandemic started, we based on the same base, we built a UV disinfection robot for malls, for schools, hotels, and hospitals. So we added more batteries and we changed the wheels so that the robot could move sideways. This is a cart puller or Titan. It's an autonomous tow tractor. And this is a greenhouse near Vancouver. And this is the last one I'm sharing here. It's a smaller autonomous vehicle. It's off-road for berry farms, so that the pickers can collect berries and the robot would move it to like a collection station. Okay. But you might ask, why software? There are many reasons for software like to be the topic of today. I have a few articles here. The first one is why software is eating the world. So oh, by the way, I'm going to send you this link in the chat area so that you also have access to this, and maybe later you can. Oh, sorry. You can read the articles. Well, I can give you one example regarding the way that hardware and software development is going. As we progress, hardware becomes the part that is common, and then the actual functionality is determined by software. So there are many examples, such as like communication radios, like that are defined using software. Or the other example could be the robots that you just saw, that the functionality is actually created in software. The other thing is the economic effects of software. You have seen that like many businesses depend on Instagram, they depend on Google Maps, Facebook to find their customers. The other part is like maybe more recently is cryptocurrencies, who are creating new ways for people to exchange value. And maybe blockchain is even bigger than that. So on the base of blockchain, there will be smart contracts, and they can fundamentally change the way we are doing things. For example, banks now are centralized, but maybe in near future we will have DeFi, decentralized finance, without any central control. The other thing that we have experienced is the social effects of software, like the effect that social networks such as Facebook, they have on the result of elections. And one thing, especially with the pandemic, that is more obvious, is that software makes it possible for people from around the world, people who have never seen each other, to work as a team together. And maybe a good example of the outcome of this collaboration is the open source software, like packages that we see. It could be an operating system like Linux, or it could be the tools that we can use in our day-to-day work, such as, and if you are not familiar, I really suggest that you look for open source alternatives to the tools that you use. For example, GIMP is an image editor. It's really good, and it for me at least, it can totally replace, for example, Photoshop. The other aspect of software is that changes are happening a lot and very rapidly, and this is both good news and bad news. Maybe the bad news is that if you knew some like software tools or programming languages a few years ago, now they might be useless. But the good news is that it's never too late. So even people who have been there for years, they might not know the most recent technologies, and there are always opportunities for people to start in software. So I will talk about different aspects, and I will try to be as short as possible. We will have a short workshop here. Hopefully, one of the remote audience can help me here. So this now I'm talking about how software makes it easier to work as a team. One of the fundamental tools that it's very natural for software engineers, but maybe not the rest of the people, is version control system. So that you always have one version of the work, and like it's always clear for the team what is where, so there is not much confusion there. And version control maybe started with software, but now that there is a lot of data used in software projects, you should have version control for data as well. So there is something called FAIR principles for data. It suggests that data should be findable. It should be easy for everyone to find the data. Should be accessible. When they find it, they should be able to use it. It should be interoperable in the sense that you should be able to use any tool that you want with that data. It doesn't have, it shouldn't be restricted to one kind of a tool. It should be reusable. So that's fair for data. The other thing is that maybe when we want to start a software project, it's a good idea not to reinvent the wheel. So it's better to break the project into smaller pieces and look for existing implementations of those pieces. And this is how, let me, by the way, this website that I'm referring a lot, it's called the Turing Way. And this is, I cover a lot of topics from here. It's a really good read. So Open Read is about being publicly available, being reusable, and being transparent. And you need open data, open source software, open hardware, open access, and open notebooks. And I will show you an example of an open notebook later. What I mentioned to break your design into smaller pieces is modular design. So if you have modules in your design, this example shows a broom, so that the head and the handle of the broom are the pieces, but the way they are attached together, basically the interface, if it remains the same, if you break the handle, you can change the handle. If you you break the head, you can change the head. And if you look at the end broom, it doesn't have any components shared with the first broom. It's as if it's totally a new broom. The only thing that is shared between them is the interface. So as long as you keep that interface, you can change the modules, and you can keep updating and repairing your system. In finding those modules, GitHub is your friend. I will show you examples on GitHub. There are other websites similar to that that contain repositories of software, such as GitLab and Bitbucket. But most people are on GitHub, and your profile on GitHub kind of shows like your work or your history. So it's if you don't have a GitHub profile, it's really good to create it. So some of the problems that happen when you work on a software piece is first, you have written something like 2 months ago, a few years ago. It used to work, but now it doesn't. The other thing is that when we work as a team, so one team member says that, okay, I'm done, and delivers the work to the other team member, but it doesn't work on the new team member who received the work. So then the question is, oh, this is not working. What happened? And the original developer is like, oh, it was working on my computer. And then there could be also a confusion about which one was the latest version. Again, going back to the Turing way, and this does not only apply to software, or maybe I can say that software has different shapes. So even a scientific paper, a research paper, can be seen as software. So this table kind of shows you what you can use to create a reproducible environment, so that the other person can get the same results. So it's divided based on your application, if it's graphical or it's command line, and the fact that if you want to just share your software, or you want to share your software with the whole operating system. I will show you an example of Binder. Conda is basically an environment in Python, and this is VirtualBox and this is Docker. However, at least at AAS, we are using Docker also for graphical applications, so it's not limited to that. The other topic that I want to share with you is using specific ways that is very common, again, for software engineers to write technical documents. One of them is Markdown. So this is an online Markdown editor. On the left, you see the source file. It's just a text file, but with just a few characters. For example, here you have this like hashtag Dillinger, and then it becomes the.
Yes, John. Sorry to interrupt.
Okay.
Can you make it a little bit larger? Because people are watching through our laptops. It's a little bit hard to see.
Okay. Let me try. Oh yeah. Okay. And when you have two hashtags, then it becomes a subsection. This is how you include a picture. And what else? For example, bullet items. It's as easy as that. And if I go to the other side, you see the output. So with something as simple as a text file, you can create an output that looks nice. And I have here a link to a cheat sheet for Markdown. A tool that is really important here, and it has helped me a lot, is Pandoric. So my problem in my previous job was that I would write reports in LaTeX, and I would create the slides in PowerPoint. And then when I wanted to work in PowerPoint, I had to reproduce the formulas, which was really hard. So Pandoric, the graph you see here, it converts like all sorts of text formats or document formats to each other. However, to make it easier, there is a development or IDE environment called RStudio, which is for R language, but recently they are supporting Python. And here you see the outputs that you can get out of Markdown easily on using Markdown on RStudio, but behind the scenes it's running Pandoric. So from the same Markdown file, you can get HTML, PDF, Word, handouts, and different outputs. Okay, and Shiny, this one is not active. Shiny is a way to create interactive applications. For mathematical formulas, you can use KTech. So again, with text, you create your formulas, and then the output is a beautiful graphical formula. For people who are in academia and who use like references, they have a lot of references, and they need to cite them in papers. There are different tools, Kika, Jabref, Mendeley, Zotero. So these are really helpful in resource, like reference management. So this part, the last part I was going to say that a lot of these things, when I saw them, they were for English language. And as soon as you change your language, it's some of them are a little bit more limited. And when you change to a language that is fundamentally, I would say, different. Example is Persian, Arabic, and Hebrew, that you write from right to left. Then the tools used to be very limited, but now they are much better, including the tool that I have created to create the notes that you see. So I think now is a great opportunity for us to expand the use of our languages if it's different from English online. So the tools are there, we just need to learn them and use them. Very quickly, I told you about developing a website or a web application. If you want to follow the standard way, there needs to be a graphical design with tools such as Figma to just design the way the app would look like and mimic, if the app would work, how it would look like. And then the one person needs to sit and write the front end. Front end is basically the part that a user interacts with using HTML, JavaScript, and CSS. Again, most people don't write it from scratch, so there are libraries that they use and then backend. So the data that you have online or the functions that you want to run, you need to write a backend. There are different languages to write backends and different libraries. And if you have a database, you need to know SQL to communicate with that database. So this is maybe not, this is just too much for someone who just wants a simple website. There is a shortcut that's I am using myself. It's called Jamstack, JavaScript API markup. So these are static website generators that starting, many of them starting from Markdown files that we saw together, they can create a beautiful website. So like you have like different templates and you can create like project documentation, personal websites, and so on. The other application that you can use, like not necessarily as a software engineer, is for e-learning or teaching. If you are a teacher, you want to help your students. Again, you can use Markdown to create lecture notes. I'm just showing you an example that I have created. It is on GitHub, so the source code is there. One output that you can get out of this, it's an introduction to convex optimization. So this looks like an ebook. So there is introduction, there are definitions with formulas and everything. And then what's interesting is that this one includes Python code that you can actually run and see the results. But here the code is not active. What I told you about reproducibility, the point is that people should be able to run your code without problems. So there are websites for that, just to host that environment. In this case, it's mybinder.org. So I have a button here. If you click on it, it starts to create a, let's say, it's a Docker container, or let's call it a virtual computer to run the code. So it's going to take some time to create that environment. But when it comes up, you're going to see oh, this time it was quick. Maybe the server is not very busy right now. Still, it takes time to show the notebook. So this is, yes. So this is the notebook. It's another output of the same information. It's a Jupyter notebook with the same definitions and formulas and everything. But this time, the code is something that I can run. Hopefully it's not gonna break. Let's see if I can get the figure.
Can you make it larger?
Yeah, sorry. So I'm just, oh, now that now I can't run it because I don't have the button. But the idea is that you can run the code and get the results. And this is like, if you compare it to what we were doing in the past, we would just get a print of a paper or a PDF of a paper. And it would took us a lot of time to reproduce what the other person had done. And then we would try our own ideas. But now if you have something like this, you can already start from the last point that the other person created. And if you want to see more of these examples, there is a website. Oh, sorry, it's the other way around. The website is called paperswithcode.com. So on this website, papers are papers, PDF, plus their code on GitHub, usually on GitHub. So this makes it much easier for people to see what's going on, to try it on their own problem and make improvements and publish new papers. And maybe this would actually increase the visibility of these papers, because many more researchers can use them. So it's an encouragement for the authors to share their code. The other point is that you can have tests online and slides. So this is an HTML slide. It's online. This is a presentation I created many years ago. And if I press escape, you're going to see all the slides. And again, the source of these slides are Markdown, the format, the text format that I shared with you. Okay, I shared everything up to this point. Now we will have a mini workshop. So from the people who are remote, I'm not sure if anyone can help me now. If you have a GitHub account, but you haven't done much with it so far, I think it would be great to start now. If we have a volunteer who can join us. And I will, so while you're thinking about it and check your GitHub account, I'm just going to tell you what we are looking at. So this is, so on GitHub, you can have personal profiles. You can also create organizations. So this is an organization I have created on GitHub. It's called eLearning Hub. And I have many examples that I hope they are easy to use for people to, as a starting point, to create different like websites or documents. So here are a few examples of personal websites that you can create. Let me click on the demo to see what the outcome would look like. So this is basically a template that you can enter your own information. And if I go to the main link, it's a repository on GitHub. And in, for example, inside content, there are let's say, let's go to home and contact. So there are, these are basically Markdown files that I mentioned that you can edit. And maybe this is a good time for me to talk about actions. So when you edit them, there is an automatic action that is triggered, and it generates the website. So there are a bunch of examples for personal websites. There are examples for websites for project documentation. If you want to create documentation for a team, these are the things that you can use. For example, the notes that I shared with you, I have made them using Docusaurus. This is the output that we are looking at. And again, all the pages are created with Markdown. Another example is Hugo. This is something written with the Go language, and it's used as a tool for project documentations at Google. The other thing you can do is to create research papers using Markdown. So in this repository, there is a source folder, and we have a journal paper. So, by the way, GitHub is able to display Markdown files in a nice way, as you see here. But if I click on raw, you will see the actual text. And then when you edit this file, what happens is that, maybe actually I can do that now.
And if you enlarge it, I appreciate it. Also, please be mindful of time, because we want to give our guests time to ask questions and engage in the discussion.
Okay. So maybe I just change the dates, for example. And commit changes is similar to save. And when we go to actions, you see a new action has started. So this is like a computer in the cloud who is running a program to generate the PDF output. And if I go back, okay, now it's successful. So if I click, I will see the paper here. It's actually a file that it's a zip file that I download, and when you open it, the PDF file is there. Just maybe last example here I will share with you, and then we will go to questions. This is something that I created. Again, maybe I'm using Markdown too much, but the idea is that you can convert 2 text files into a video. So you have a Markdown file for the slides, and this is very simple for now. I just a demonstration. The first one is the slides. The second one is the voice over the slides. Let's say you want to give a presentation. And what happens here is that the slides are generated. Basically the second file is converted to voice, and then in the end it's put together as a video. I'm not sure if you can hear let me try.
I'm very excited to work with you. I have a secret to share with you. I am not a real person. Now that we got that out of the way, I'm going to help you share your knowledge with your coworkers. Today, we will be talking about Markdown. The slides that you see here have been generated.
So, and I think the benefit of doing this is that it's very easy to fix mistakes. So if you record something and you make a mistake, it's really hard to go back and to fix it. But in this way, you just change a text file and then it regenerates the video. I'm going to stop at this point, and yeah, let's go for questions, or if someone wants to try it, we can quickly try something together.
If somebody wants to try it from the remote guests, please raise your hand. And if not, let's go to the in-room audience, and then we alternate between in-room and remote audience. Mohsen, does anyone have their hand up? Okay. Right. Anybody who wants to go for questions?
Will you share the website on
Sorry.
question for you? Will you share the link of the website on?
Will we share the link of the website on Telegram? Yes. Okay. Yes. Folks, it's your opportunity to jump in. It's so quiet. All yours.
Hello, Behzad. Thank you very much for the presentation. Louder?
Yeah.
Thank you very much for the presentation. My take on the first part was that, advanced intelligence system is working on the robot, deliver services for people and businesses, and actually got connected to the value proposition of AIS. But one problem with the second part was that it was kind of very mixed with jargon and all words. So for me, it was kind of something that I related to. I got connected, but for layperson or someone who doesn't have background in software development or product development, I highly appreciate if you can tell, those friends, those people who are not in this field, that basically with these version control system or teamwork working platforms, what problem we're gonna solve and what we are looking for developing our team. So we need to work with some softwares like, for example, Jira, GitLab, GitHub, and so on. Yeah.
So maybe I repeat the question, and if I missed anything, please let me know, because the audio is still not really good. So the question is, why do we need to use a version control system or GitLab or Jira, for example, to develop software? So there is a big difference between developing software for yourself and your research project and working as a team. And working as a team is something that it's really hard to find like the same rules that apply everywhere, but there are some tools that have been tried over and over again, and they help us to maintain a single source of truth. So one important thing as when you work as a team is that everyone knows what is the latest, or if you use, for example, Git, a version control system, you can create tags that those tags, the content of those tags cannot be changed. So when you talk about version 0.1, everyone can go and check 0.1. But if, for example, we don't have tags, the problem is, and we have experienced this at AAS when we were not following some best practices, that two teams were working independently and everything was almost working, but not quite. And this could take weeks because each side was making a slight change on this side and the other team a slight change on that side, a little update here, a update on the other side. And yet still, when we wanted to demo, things wouldn't work. But when you have a version control system and you have tags, you can specifically say, okay, so for this team, this tag works with this, like the output of this team with this specific tag. And then you can work towards the next step. And the next step, again, you can tag it, and those will always be there. So that's one simple example of how like version control system can help a team.
And for someone who doesn't have a background in software development or product development, for someone, for example, in oil and gas, how you define the value that these team working for version control software deliver?
Mohsen, I think you need to help me. I didn't quite get the question. Sorry, the mic is mute.
My apologies, I guess.
Okay, now I can hear.
One more time. Sorry to interrupt. Amir, if you unmute your computer, and Mohsen, if you could mute, I think I can hear better. Did you hear that?
There is echo, and it's a little bit. When you unmuted your computer, Amir, I think it was easier because it's fairly close.
Okay, my question is that for someone who doesn't have any background in software development or in IT, how you define the value proposition of these version control or team working services and products?
I think I answered this question. You had a follow-up question. Oh, your question was for someone who doesn't have background.
Yeah.
Okay, so so my objective here is that for people who don't have software background, I think the what they have done so far, most of them, they have ignored a version control system. I'm just trying to show that it is possible to, for example, as I showed you here, to use a version control system as another way of saving a file. So when you commit a change, it's as if you are saving a file. So you don't have to, and especially if you start using version control system, and maybe here I'm talking to like non-software engineers. If they start using version control system for their personal projects, in that case, it's going to be much simpler to use. Then they learn skills that will help them in their future job, like in a company when they are supposed to work as a team. But I totally understand that for some people, this might be just too complicated. Even, for example, data scientists. So CERN, the nuclear research center in Europe, they have like 16,000 scientists from all over the world working for them. And usually their background is not software. So they have created a kind of a versioning system for Jupyter notebooks. So they don't use Git. They just have a system to take care of like version control of notebooks and data sets. So to your point, it's not for everyone. It might be complicated, and there are other ways, but this is the way, like using a standard version control system such as Git, it has scaled really well so far. So as I said, it enables people who have not seen each other, who live in very like far areas from each other, to work together to create a single product.
Awesome. Anybody else? People in the people who are online with us, please jump in.
Can I ask a question?
For sure.
Behzad, thank you so much for your presentation. It was really helpful. I have a question. I know that you have been working with lots of these document, I don't know how to say, software for the making documents. But I want to ask, if I want to start as my first document to be in GitHub and be as I have my first website, which one do you suggest to start with? Which one is easier to start with?
And what is the purpose of that website?
Think of a personal website.
Let me. Oh,
Not any program to be run or.
So almost all the examples that I have here, they don't require writing code. So it's very quick to here, sorry, personal websites. And when you try, so the other point for, so these ones, you just edit a Markdown file and the output is generated for you. And my other point is that when you try these examples, so again, I have tried to make it as simple as possible. After a few of them, like you find the principles of creating such websites, even if you don't know the framework that they have used. So this one is Hugo, which is written with Go language. I don't know Go language, but I can use this. The other one is Next.js. I think it's made on React, if I'm not mistaken, on JavaScript. The other one is Gatsby, again with React. ViewPress with Vue.js. Again, as some, I myself, I don't know much about like web development or maybe the details of these libraries, but now I'm able to take an existing website on GitHub and make it my own and make changes. So I think one way, and it's really difficult to find something. I hope that these ones that I have, the examples that I have here, are going to be useful for some of you. But if they're not, once you work with them, then you will be more comfortable looking for them on GitHub. So right now, when I'm looking for something, in addition to Google, I GitHub it. So on GitHub, there are so many examples. And if you know the principles, then you might be able to find something that you really want and be able to use it.
I don't need to install any of these languages that you mentioned. It's just, I just used their GitHub as an example and I changed them for myself.
It's always possible to do it on your computer, but the point of the examples that I have here is that you don't need to install anything on your own computer. It's just everything happens on GitHub online. So you just need a browser, and maybe something that I didn't show. If I quickly show it here. So while you are on a GitHub repository, if you press the dot button on your keyboard, this is what happens.
The dot button?
Yeah, dot. So the magic just happens, and now you have a code editor. It's basically a Visual Studio Code in your browser. So you can see files here and you can edit them. So maybe another point to remember is that now your computer is in the cloud, and we just need to like learn how to use it.
Thank you so much.
You're welcome.
Thank you. Thank you. All right, anybody else? But before we go to the next person, Behzad John, what should be our takeaway?
Should I say it now?
We can keep it for the end, but if somebody else wants to ask a question. Okay, people are quiet. Let's just say it now.
Okay, okay. So I have the takeaway here. You can based on what I shared, I hope now you have, if you haven't tried it in the past, motivation to learn something new in software. You need to set a target for yourself. You need to design a path and move towards that objective. It's not smooth. It requires a lot of patience. That has happened to me as well. So I wanted to learn new tools, and it turned out to be way more difficult than what I thought it would be at the beginning. But I kept going, and at some point things became more clear for me, and it was I was then very happy with the results. As you go, as I said, because of the amount of changes and the speed of changes that are happening in software, you might have to update your path. The other suggestion is that if you decide to do something like that, work with a group. Just don't be alone and try yourself. Sometimes a friend, someone who has been there before, can help you be very like solve problems in a much quicker compared to yourself trying to do things. So the takeaway is be patient and don't get disappointed.
Thank you. Thank you so much. One last call for a question, comment, anything? All right, let's take a group picture for people who are who are with us remotely. If you want to be in the picture, please turn your camera on, and Mohsen will take your picture. Yeah, please turn your camera on if you can. 3, 2, 1. So people are still turning on their camera. Okay, again, 3, 2, 1. Let's go. Did you take it? Awesome. Well, thank you so much for coming. Our next meeting will be in person. I mean, the speaker will be in person. It's going to happen here at Paparotti. It's going to be Sherwin Shahriari. Sherwin is, what's his job? He's a university professor, and he also has other qualifications in terms of urban planning and stuff. It's going to be an interesting talk. We're going to post it soon. So with that, thank you for joining us online or in person, and hope to see you next week. Bye-bye, everyone. And thank you, Behzad.
Have a good night. Bye.
Thanks, everyone. Thank you.